Good morning, students. Today we are going to discuss about the Lora technology. Lora is a wireless modulation technique. It is derived from chirp spread spectrum technology. Basically, it encodes information on radio waves using chirp pulses. So, likewise, the dolphins and bats they are communicating with each other. So, Lora modulates information, okay, and then transmits the data in the form of wireless form. So this technology is quite robust against the disturbances, and we can have long range or long distance data transmissions. So basically LoRa modulation, it is based on the chip spread spectrum technology. Now LoRa, it is very much ideal for the applications that transmit small chunks of data and with lower bit rates. Using this technology, data can be transmitted at a longer range as compared to technologies like Wi-Fi, Bluetooth or Zigbee. These features make LoRa very well suited for sensors and actuators which are operating in low power mode. So that's why LoRa is basically used for the low power applications and long range communication. So LoRa can be operated on the license-free sub-gigahertz bands like 915 megahertz, 868 megahertz, and 433 megahertz. It can also be operated on 2.4 gigahertz to achieve higher data rates. So these frequencies basically fall into the ISM bands, which are reserved for industrial, scientific, and medical purposes. So LoRaWAN, it's a media access protocol, MAC layer protocol built on the top of LoRa modulation. So it's a software layer which is basically defining how devices use LoRa hardware when they transmit the data and what is the format of messages. So basically this technology, it is developed by a company called Semtech. Okay, it's a new wireless protocol designed specifically for low power communications and long range communication. LoRa stands for long range radio. Basically it is used or mainly targeted for M2M and IoT based applications. This technology, it is enabling for use for the public as well as the multi-tenant networks, and where we can connect number of applications running on the on the same network. Basically this alliance was formed to standardize this low power wide area networks for IoT, and it's a non-profit association which is featuring membership with number of key share market holders like Cisco, Semtech, IBM, Microchip, and many more. So each LoRa gateway they are having the ability to handle multiple or millions of nodes. Then signals, they can cover very significant distances, longer distances. Then they have very important feature like the requirement of infrastructure is very less, which is in turn considers or affects the cost of the network building. So we require less cost, or it is quite cheaper and very fastly we can implement that. So LoRaWAN, they are suitable for transmitting small size payload like sensor data over longer distances. This LoRa modulation also provides significantly greater communication range with low bandwidths than as compared to other competing wireless data transmission technologies. So these are very important feature: long range, then ultra low power, then it can have the LoRaWAN has having the features like deep indoor penetration. LoRaWAN networks can provide deep indoor coverage and easily cover multi-floor buildings. So also it features adaptive data rate algorithms to help maximize the node's battery life and network capacity. LoRa protocol includes different layers and including encryption over there, which is giving us the security also. LoRa provides end-to-end security, so LoRaWAN ensures secure communication between the end device and the application server using AES 128 encryption algorithm. So these are very important features of LoRa. So if we see now, there are in the next slide we can see the end nodes over here. So in this particular architecture we can see there are end nodes, then there are gateways, there are network servers and application servers. So basically these are the main important components of this particular LoRa architecture. End nodes, these are the sensors or actuators. These are sending LoRa modulated wireless messages to the gateways or receive messages wirelessly back from the gateways. Second important component over here is gateways. Gateways receive messages from end devices and forward them to the network server. We are having next important component is the network server. Network server, it is the piece of a software running on a server that manages whole entire network. So that is the network server. So they are managing entire network. That is the big responsibility which has been taken up by the network servers. Then we are having next is the application servers. So that are having the softwares running on the server which are responsible for securely processing application data. So whatever data coming from the sensors which is being processed at this particular layer application servers over here. So end devices communicate with nearby gateways and each gateway is connected to the network server. So LoRaWAN networks use Aloha based protocol over here. So end devices don't need to peer with the specific gateways. Messages are sent from end devices, travel through all gateways within the range. These messages are received by the network server. If the network server has received the multiple copies of the same message, it keeps a single copy of the same message and discards other messages. This is called as the message deduplication. So this way it works out. And if we see now lastly the features of the LoRa, that is the range, that is 2.2 to 5 kilometers in the urban area, 15 kilometers in the suburban area. Standard, it is IEEE 802.15. Modulation, here we are having spread spectrum modulation techniques based on the chip spread spectrum modulation. Capacity, one LoRa gateway can handle millions of nodes. So it is having long battery life, and if we see the physical layer of the LoRa, it is supporting for all the power related operation modulations, signaling in between nodes and gateways. So this is very important technology which is used by the IoT devices, and with this we will stop in this particular video for the LoRa discussion. In the next video we will discuss on the OPC UA. So thank you students.